Hey, good morning, everybody. Thanks for joining us today. It's a beautiful day, and it's always a joy to have folks. You could have been anywhere today, but you chose to be here, so we really appreciate that. Before you get into your training this morning, I want to take the time to share with you some of the activity that Intel is doing to accelerate the process of AI adoption into the industry. And we're doing that collaboratively with many partners, including some of you in the audience that you may recognize some of the slides that I have here. My name is Fal Diabate. I work for Intel, been with Intel for more than 20 years. I started working for them when I was 4 years old. So I work in different positions from software development to product management and so on. And these days I manage our technical engagement with a partner like H2O.ai, partners that are disruptive, as we call them, in the AI industry and so in the database industry. I want this presentation to be an interaction. I hope to learn as much from you as you will learn from me. So please stop me anytime you have any questions. Okay.
Can you tell us about the Blue Danube project?
Yes, I will. I have a slide on that. Very good. Oh, I'm glad somebody actually know about it. That's fantastic. Yeah. So AI being a large subject of interest to many people, there are so much to talk about, but I chose to focus on three major items. So the first one is business imperative. That's more of like the problem statement of the collective we are trying to solve for the industry. The second part of my talk today would be about what Intel is actually doing about it as a company and also as a catalyst throughout the industry. And the third one would be about the specific activities we're doing with H2O.ai today. Okay. So the business imperative, I'm sure many of you have seen these pictures before, something similar to it. The idea is that AI has been around for many years. In fact, the concept has been around since the mid-50s. The term AI was coined, I think, around that time. But we noticed fairly recently a major enthusiasm about AI in general, machine learning, and deep learning in general. And we believe it's usually due to about three major factors. The first one being Moore's law. Computers are getting faster and cheaper to use and so on. The second one being the fact that open source tools to develop models and create algorithms are all over the place, right? So it's kind of like a commodity today to get some of those things. And the third one is the picture that I'm showing about the availability of data to train the model that you guys actually create and the algorithm that you guys create. It is estimated by next year, 2020, there would be about 50 billion devices connected to the internet. And there will be about 200 billion sensors connected to the internet. So when we get things like driverless cars or automated factory and so on and so forth, right? So that will generate a lot of data. To give one example, a smart factory, for example, can generate about 1 petabyte of data per day. Human being, an average user of the internet could generate about 1.5 gigs, so a ton of data. And then the question to us, the collective us, would be, with that deluge of data, a term that was made by The Economy, the British magazine called The Economist, talked about deluge of data. It is actually a deluge of data. So with all that data, what do we do? What do we do with it, right? What kind of business insight, business forecast, or accurate foresight can we get out of that data? So that's the problem we have to solve as a community. And the hope is that we can use AI to do that, right? And AI will actually help accelerate that to get value out of that data. Value being in the form of, maybe revenue generation, increase revenue generation, optimize operation, right? Reduce costs and that kind of thing. And how do we actually do those in a secure manner and in a legal manner? Right? So that's the problem we're facing. But the reality is that, with all the hype, all the enthusiasm, the reality is that the industry is not embracing as fast as, the enthusiasts like yourself wants it. This survey is actually one example showing that from Gartner, and that was actually done last year. So CIO was asked about, what are you doing about AI? 46% were kind of like, how are we thinking about it? We have a plan for it. And then the reality is that only 4% are actually doing something about it, between thinking about it and actually doing, 4%. So we have our work cut out for ourselves. How do we actually include this number to a double-digit number? So it's a problem we have to solve. So what is Intel actually doing about that, right? So I'm going to go over that. So the way we're doing this, being an ingredient or a manufacturing company, we kind of like look at this holistically. Starting with the hardware, we provide hardware or ingredient for hardware platform that span from multi-purpose processor to a purpose-built processor for your AI engagements. We also work on tools that are software that help accelerate the deployment and the creation of your model and algorithm and so on. And I'm going to go into detail to each of those. And then the solution-wise, we create kind of like a community for anybody on that stack there to get together and then get some code, get some reference architecture and whatnot for any vertical that you're creating stuff into. So let's go into each of those one at a time, right? So starting with the hardware, so whether you're doing your AI activity or AI project for the end device or for activity on the edge or in the data center, we do have some product available for those and some solution available for those. Some of those hardware could be multi-purpose, like a Xeon processor. Some of them can be a specifically purpose-built processor. Some accelerator, for example, like Gaussian neural accelerator on the endpoint. And for some of you doing some work around the autonomous vehicle, we do have Mobileye. I guess some of you heard that we acquired a company in Israel like a few years ago. Fairly expensive if you ask me, but I guess it was worth it. And so you use that processor for that, and you have a set of SDKs and tools for that as well. On the edge or in the data center where most of these data crunching and model consumption is actually happening, whether you're doing training or you're doing inference, Xeon is always there for those things. Okay. So that's basically around the conventional hardware as we know of it today. I put this picture in there to show that beside those accelerators, we're also working on some, I call them futuristic type of processors. The neuromorphic computing chip is one of those examples. And the idea of the neuromorphic computing is to learn from, neuroscience, from science in general, from material science in general, and incorporate some of those learning into computer architecture so that the computer will actually think as a human being, right? The neuron and so on. So if you're doing your modeling with conventional CNN or RNN, those type of activities, you will be moving now into what they call, at least in that world, what they call the spike neural network. Right? And there is a community around the neuromorphic computing chip today. Mainly it's university and the major government that we're working with. And they're doing some testing on those today. Right? The other picture is also about a project for our quantum computing chip, Tango Lake. That's also an experiment that won't be available soon. But I just wanted to share with you that we're working on some of those things. So that's kind of like a long way before we get there. But in the meantime, we have to deal with the reality of working with the the conventional processors that we have. And for those, we need software. And part of that software is what I'm actually showing in this picture. It looked very busy, and I'm going to try my best to actually go over each of those. I think it's also busy for a purpose because, there are so many open source projects out there, and how do we actually make sense of those? So who do we target? Who's going to make a benefit out of each of those? So if we start with the top one, the toolkit. The toolkits are essentially, as the name is, toolkit that we provide for developers in general. So if you're doing a deep learning type of development or deployment, we have the OpenVINO. How many of you are familiar with OpenVINO? No. So OpenVINO is an inference neural network optimization toolkit that we have available for folks. And it's not only a toolkit for Intel processor, but all kind of processors. So whether you have GPUs or accelerator, you can actually use that to improve the accuracy of your model, right? And it's there for free. The Movidius SDK is also the same thing as well. So to basically get the most goodness out of your processor, you have those SDKs that will basically help you improve the accuracy of your system. In the middle layer, so if you're doing machine learning type of development, and I'm sure many of you are doing those, so whether you're doing classification, linear regression, whether you're doing clustering, dimensional reduction, on any of those type of things, and I'm sure you'll be using popular languages like Python or R. Survey shows that those are some of the ones that most people use. What we did, we basically optimized those languages for the underlying architecture, right? So we did everything we could to get the goodness of all the Intel portfolio processor, the one that I showed in the previous slide, and to expose that into those languages for you to build the most accurate model possible for you. And if you're doing deep learning activities, if you download TensorFlow or Caffe or MLLive, for example, or Big DL or one of those Spark-related framework, we optimize those as well into the Intel architecture, and it may be transparent to you. But what I will encourage you would be that if you download those, please make sure that and you're running on Intel architecture, whatever the architecture may be, please encourage to find out if those frameworks are optimized to Intel, because if you don't, you may be missing or you may be losing some performance gain that you're leaving out, right? Because we optimize all of those popular frameworks on our architecture. And like I say, it may be transparent to you as well. And underneath the libraries are kind of like primitives code that are actually the engine that make those Python and R, performance as I was describing. And the engine that make those, a couple of those are, for example, DAL. DAL is Data Analytic Acceleration Library. It's basically a set of library. The MLK DNN is also the same thing. MLK is math kernel library. MLK actually been around for many years. So for those of you in the scientific industry doing, things like fast Fourier transform or vector math or any of those things, been using math kernel for many years. So we leveraged the knowledge of that team and embedded those teams with our neural network team to come out with primitive that can benefit model creation, framework optimization, and so on and so forth. Okay. Any questions so far? Okay. And last not least, on the deck that I showed, there is a solution. So this solution is kind of like a marketplace, so to speak. It's a one-stop shop for folks in the industry like you. Some folks may be on the business side of things. They can take advantage of this to find out more about collateral, learn about case studies and reference architecture and whatnot in the industry. We put those into what we call the builders, builder.intel.com. And the builder program is one of those programs that have been around for many years as well. I remember back in the days, we started with the Cloud Builder program. And that was the idea there was to create a federation or a community around cloud. When people were deciding, should I go in public cloud or create my own cloud or a community cloud or what? So we created that to create our community and go forward with that. So that was very successful. We expanded that one to the network builder program for the connectivity issues, leading today to 5G. So you have a community around that as well. And then the storage builder, and today we have the AI builder program. I encourage every one of you to actually go to this site and, ton of nuggets there. You may learn something or two. Okay. So this picture is basically showing that, the advantage of taking, it's basically showing the fact that if you take advantage of all those ingredients that I was talking about, those optimization engine that I was talking about, you can get some tremendous performance out of it. This particular one is about a gen-to-gen comparison. Current generation of Xeon compared to the previous generation of Xeon, running Google Net with Café running on it. Right? And then what we noticed that that's an internal thing that we're doing. What we noticed that if you and the new generation was optimized with all the bells and whistles that I talked about, the frameworks and the libraries and so on, the marketing libraries and so on and so forth. And we noticed something in the neighborhood of 277x, net percentage x for inference, and 241x for throughput, just to show that the power of that optimization. Now, let's take some time to talk about what Intel is doing with H2O.ai. What are we doing with them and so on. So I love this picture. Ian and I were talking about this earlier. This is actually not a Photoshop. It's an actual picture that was taken, a couple of days ago, because Monday? We put that on Monday. So if you go to you're going to San Francisco Airport, in and out, one northbound or southbound on 101, you will see this picture. And it's a testimonial of Intel commitment to work with H2O.ai into making AI a democracy, to make it pervasive into the industry, right? And I think we're all actually working into making that, right? We want to make sure that as many people get involved, as many people solve their problem using some of those tools that we have there. And so just like the gentleman was saying earlier, if you went to H2O World last year, we made this announcement about Project Blue Denim. And the announcement essentially is to make sure that we increase the adoption of AI into the industry. And specifically, what does that mean? That means we enable H2O.ai technologies and tools to run based on Intel architecture. It's that, if I can put it simply, that's what I would say. That's the goal. So between that announcement and that goal and the actual availability of super performance H2O.ai platform running on Intel, there's a ton of work to be done. And we're working on those as we speak today. My particular role at Intel, or part of the hat that I wear at Intel, is to ensure for that product to actually work, right? So we meet, even yesterday, we meet with our engineering team on both sides, meets on a regular basis to make sure that becomes a reality, to optimize some of the product that I will show in the next slide. And we believe that this marriage would work, and it kind of makes sense because, if you look at the strength of Intel with, the extensive IP that we have in the industry, the comprehensive ecosystem that we have, and the fact that we're customer driven. We always about opening out the process and increasing the TAM, so to speak, the total available market. And you combine that with the momentum that H2.AI have today, the humongous number of download that H2.AI have in the industry for the product and so on. And the fact that they committed to the democratization of AI, it just makes sense for us to be together, and we're working toward that. So what does our stack look like? The overall solution we're providing, what does it look like? It will look like something along these lines, some of the things that I'm showing. So underneath, as always, you will have the portfolio of Intel architecture. So whether you're doing something related to the compute side or the storage side or the networking side. The layer above that, the libraries and the framework are optimized to take advantage of those. And again, that's all transparent to you guys if you're if you're data science or software engineer. You don't have to do much here. What you have to do is, on the second layer for the optimization to ensure that if you're using an open source a platform out there, an open source framework, to ensure that library is actually embedded into that, right? And then our work and my work is to ensure that, product like driverless AI, you're gonna get some training on that today. Or if the open source version, I think is H203, right? Or if sparkling water for the Spark, combination of Spark and H2.AI, any of those products, it's in our roadmap to ensure that those work best on Intel architecture. And so that when you create your model or your algorithm and you're solving some solution, whether in FSI, in the financial industry or retail or manufacturing or what have you, your model is accurate, your solution is fairly accurate. And whatever value you're trying to get, when we go to that slide there, the insight you're trying to get or the foresight you're trying to get is as accurate as possible. Essentially, that's the goal. So all the work we're doing is to make sure that when you develop your product for the end customer, and the end customer said, oh, you actually, you exceed my expectation on what I was, what I was hoping to get. The value that I was hoping to get is actually over the top. And we want to make sure that we, H2.AI and Intel, are part of that, that process, right? At least in the background, right? Okay. So this is my last slide, and it's a simple call to action, very, very simple. Work with Intel and H2.AI. H2.AI has a tremendous momentum. There's tremendous buzz about, you guys into Intel today at pretty much every level. I believe in April 2nd, we're doing some announcement about some of the latest products we're announcing. And, I want to say you guys cut the line, actually, because there's some process for H2.AI. Because I cover some, my team managed some other partners as well. But H2 literally cut the line to get into this. And that's mainly due to the fact that the momentum is so unbelievable that we had to create a separate path for you guys to be in that stuff. So visit our sites, visit H2.AI. I'm sure you're probably doing that already. But maybe you're not visiting software.intel.com. That's a major repository for many of the software engagement activity that we have for the open source community and so on. 01.org is also another one. Within our software group, there is a team that is focused specifically on everything and anything related to the open source activities happening in the industry. From the Linux kernel to all the framework and so on and so forth. And most of the product that they get involved in, all the Apache product they get involved in, are mentioned in one way or another into 01.org. So I encourage you to visit that. Okay. Thank you for listening. Yeah, go ahead.
Would these slides be available?
Yes, yes, they will be. Yeah. So I will give it to Ian, and Ian can distribute to folks as well.
Thank you.
And it's also being recorded too, so we'll send it all together for you.
Any questions? I think we have time for a couple questions. Oh. All right. Thank you very much for listening. Oh, yeah. Okay.
GPUs that are coming, how is Intel addressing that GPU?
GPU? We're actually working, so we always have like a GPU embedded in into our laptop and so on. But we came out last year to say that we're going to create our own discrete GPU. And I believe we came up to say within the next couple of years you should see that. So yeah, so we hire a bunch of folks from Apple and AMD, very, very smart folks who came from those companies, and they're working on creating a discrete GPU for Intel. I believe we came up to say in the next couple of years, so 2021 is when we're going to have that. Yeah, great. Thank you.
So what's your opinion about TPU? So is there any concern?
TPU, yeah, there is always a concern when some of those big cloud vendors, Google probably being the first one. I believe Amazon is doing their own thing. When they come out with something like that, it's a concern. But it's also an opportunity to up our game, right? Because we know that many of those companies, they're going to come out with something that works for them. And then we have to make sure that we're valuable to them by creating some acceleration and so on and so forth. And we're doing that. So besides the GPU, like the gentleman asked, we're also working on some accelerators that can compete with those, hopefully so that they can forget about doing that and focus on what their core competencies. And so, so we're working to address that in that fashion.
When can we expect output from Blue Danube?
Blue Danube, that's a very good question. I think after the announcement, I would say probably within a year. Yeah, within a year.
Could you repeat that question, sir? Could you repeat the question?
Yeah, the question was when would, I forget what the question was. When would we expect results from Blue Danube, the project between Intel and H2O?
Exactly. Between the announcement and now, when will we, see some tangible result related to that? I'm sorry? Right. So the announcement was made in February. Like I said, I think within 1 year, to be realistic, we will see some tangible result. Yeah, we'll see some tangible. Yeah, you bet. I think the gentleman had a question.
You mentioned that maybe more recent versions of the Intel architectures on the CPUs have this 200 or 400-fold improvement on deep learning tasks and training.
Right.
Is there a way to query, if you have existing, I'm at an academic institution, they just bought new chips for their cluster. Is there a way to query whether or not a given processor is in this? Yeah. Is this associated with a given version number or, these
Of optimization for deep learning. How does one tell whether or not they're getting that?
Right. So there are some ingredients that were not embedded in some of the previous versions. So if you take Haswell, for example, super multi-purpose, jack of all trades, right? And if you go to some of the recent ones, starting with the first generation was Skylake. This particular one was basically done with Skylake. And the next, right, so from Skylake moving on, there was some sense of really focusing on stuff related to specific training and then specific inference scoring for those.
So this will apply to all of the Intel line from Skylake on.
Skylake on, exactly. Right, Skylake on, yeah. Okay, thank you very much, guys.